Chapter 9 is about polynomials and factoring. So the first thing we're going to learn how to do is to describe a polynomial, and then we're going to add and subtract them. So by the end of this lesson, you should be able to do those two things, describe a polynomial and add and subtract them. So a monomial is an expression that's a number, a variable, or a product of a number and one or more variables. So mono means one, and a number, a variable, or product of a number and one or more variables means multiplication. So each one of these is a monomial. 12 is just a number, y is a variable, and then negative 5 x squared y are all multiplied together. So that's one monomial. And then this right here is technically c times 1/3, but we don't write it like that. So it's a product of a number and a variable. So it's important to know that you can have a number on top, but you can't have a number on bottom or a variable on the bottom because there's no way to multiply by that. And we'll talk more about that when we get into chapter 12. So the degree of a monomial is the sum of the exponents of its variables. For a non-zero constant, which is just a number, the degree is 0. And the number 0 has no degree. So a degree is just a way for us to classify these polynomials. Eventually we'll talk about what this does to the graphs of each of these polynomials, but right now you just need to identify the degree. So if we take a look at this first thing right here, you always go to your variable. And in this case, you just count the number of variables. Since there's just one x there, the degree is 1. For this next one, you take a look at your variables. X squared means you have 2 x's and 3 y's. So all together you have 5 variables. That's the degree of that monomial. And then negative 4 is just a number. So up here it says for just a number, the degree is 0. And that's because we could technically write this as negative 4 times x to the 0 power. And we know that's just negative 4 times 1. Which is just negative 4. There's 0 variables in that expression. So then a polynomial is a monomial or the sum or difference of 2 or more monomials. Poly means many. So sum or difference, add or subtract 2 or more monomials. So each one of these guys here is a monomial. And then when we start adding or subtracting them together, this whole thing is called a polynomial. So the polynomial shown above is in standard form. Standard form means that the degrees decrease from left to right. So if you look here, you start with your 4, then you go down to 2, then to 1, and then to 0. We like writing things in standard form just because they look nice and pretty. It's like we put things in alphabetical order, kind of a deal. So the degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. So the degree of this guy here is 4. So basically when you put a bunch of guys together, the biggest exponent takes the whole pot. So when, again, we start talking about the graphs of these things, this will look a certain way because the highest degree is 4. This other stuff will have an effect on the way that the graph looks, but not as much as the highest degree. So after you simplify a polynomial by combining like terms, you can name it based on its degree or the number of monomials it contains. So let's talk about the number first. So you're going to see words like bi and tri and mono. Bi means 2, tri means 3, and mono means 1. So when we take a look at this polynomial over here, 7x plus 4 has 2 terms, so we call it a binomial. Where this 3x squared plus 2x plus 1 has 3 terms, so we call it a trinomial. And then 4x cubed is just 1, so it's a monomial. Now the other way that we can name things is by their degree. And we've had the most experience with this degree right here. Things that are linear just have a degree of 1. So 7x plus 4, if we were to graph this, it would look like a line. That's why we call it linear. Whereas something like this, if we were to graph it, it would look like a parabola. And the fancy word for that is quadratic. So if something has a degree of 2, it's a quadratic. something has a degree of 3, we would say that we're cubing that, or x cubed, so it's called a cubic function. These look like this. And then something to the 4th power is called a quartic or a 4th degree polynomial, and they kind of look like squiggly W's. And then something without a degree, like x to the 0 power with a degree of 0, it's called a constant. So there's nothing that can change in there because there's no variable, there's no x. So you need to memorize bi, tri, and monomial, linear, quadratic, cubic, 4th degree, and constant. Because you'll be asked to do problems like this, where it says write each polynomial in standard form, then name it based on its degree and its number of terms. So when we want to write things in standard form, you look for the highest degree. So we got 2, 0, and 4. So the 4's got to go first. So all we're going to do is just rearrange this. So negative 9x to the 4th, then bring that guy in second, and then follow up with that one. So you don't change anything, you're just rearranging it. And then we're going to name it based on the degree and the number of terms. So I'm looking at the degree. Its highest degree is 4. So if we go back here to our table, we call it a 4th degree. And then you count how many terms. We got 1, 2, 3. If we go back to our table, that's a trinomial. And that's what we would call that thing. Let's try C. So when I'm looking at C, this has a 0, this has a 1, and this also has a 1. So we can combine like terms. So if I have 7v's minus 11v's, because they have the same exponent on the variable, all we get to do is add or subtract the numbers. So 7 minus 11 is negative 4v, and then we have just this plus 8 hanging out. So once we have that, then we can name it based on its degree, which is 1 here, so linear. And the number of terms, we got 2, so binomial. I'm going to save this one for your can you prove it. So now let's get to the adding and subtracting stuff. Simplify each sum. Basically all we're doing here is combining like terms. The parentheses only purpose is to show you that this is one polynomial and this is another polynomial. When we're adding this, there's really a positive 1 right here, but we know if we multiply a positive 1 here, nothing changes. So if it makes you feel better, rewrite all this stuff without the parentheses, and then all we got to do is combine like terms. So this has an m squared, and so does this. So if you have 12 of them plus 8 more, you get 20. And then these numbers both don't have a degree, so we can add those. 4 plus 5 is 9. And then we're done. That's it. Now there's another cool thing that you can do, and it's kind of like back when you learned how to add, is you can line things up. So like this and this are both a t squared. So I could rewrite this as t squared and then minus 6, and then put 3t squared plus 11 over top of them, and then just add. So just like before, you'd add like everything in the tens column and everything in the ones column. Same thing here. So we'd combine negative 6 plus 11 gives us 5, and then t squared plus 3t squared gives us 4t squared. And that's it. I personally don't like rewriting it to make them over each other, so I tend to just combine like terms, but it's totally up to you which way you choose. We'll leave C for you to do on the Can You Prove It, but let's talk about D. So D is a little strange because if we start looking at like terms, I have 2p cubes plus 9p cubes, so that's easy. I just get 11p cubes. And then next I'm looking for squares because I want to write this in standard form. So I have 6p squared plus 11p squared, 17p squared. And then I'm looking for p's. So I got 10 plus 3 gives me 13. And that's it. Be very careful that you don't end up combining these things when you're done. They have different variables on them, so they can't go together. Subtracting is a little harder. That's why we do that one last, because you need to remember to subtract everything in the second set of parentheses. So this stuff right here is going to stay all the same. This v cubed plus 6v squared minus v. But everything here needs to be subtracted. So what I like to do is pretend this is a -1. And then since there's parentheses there, I'm just going to distribute it. And what you end up doing is changing the sign on everybody inside of here. I want to subtract a positive 9v cubed. I want to subtract a negative 7v squared. And I want to subtract a positive 3v. So then once it's written like this, it's literally just addition. So you do v cubed minus 9v cubed gives you negative 8v cubed. And then squareds. So 6v squared plus 7v squared is 13 of them. And then finally, minus v minus 3 more v's, so it gives us negative 4v. It's in standard form. We can't simplify anything else, so we're done. I want you guys to try these next two on your own for the can you prove it. So that's it. You should be able to describe them by their degree and number of terms, and then you should be able to add and subtract them. So you got 2 problems here to do, 1 problem here, and 1 problem there. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.